Let's be honest, in the age of hyper-realistic AI, how can any of us really trust what we see online anymore? It's a huge question, and today we're going to dig into a potential answer, a technology called digital provenance.
And look, this right here, a comment from a Reddit user, it just sums up the whole problem perfectly, doesn't it? You see an image, and it is so convincing, so real, your gut reaction is to just believe it. But then that little voice in the back of your head kicks in, screaming, wait a second, is this actually real? This isn't some niche tech problem anymore. This is something we're all dealing with.
You know, for the longest time, a photo was evidence, a video was proof. But generative AI has completely dynamited the line between what's real and what's fake. It means that old saying, seeing is believing, well, it just doesn't really apply anymore. So, what do we do about it? Well, there's a huge coalition of tech and media companies working on a new standard to try and bring some transparency back to the table. You can think of it like a verifiable label for digital truth. Just imagine this for a second. What if every single photo, every video, every audio file you saw online came with its own secure, built-in logbook? A logbook that could tell you exactly where it came from, who made it, and every little change that was made to it along the way. That right there is the big idea behind digital provenance. And this is no small-time operation. We're talking about the Content Authenticity Initiative, or CAI. It brings together thousands of members. You see some of the big names here, from tech, from media, from academia. It is a massive global network, and they're all pushing for one shared goal: to create a single open-source standard to fight back against all this digital disinformation.
And the standard they've come up with is called content credentials. Honestly, the best way to wrap your head around it is to think of it like a nutrition label on your food. Before you take a bite, you can glance at the label, see all the ingredients, see where it was made, how it was processed. It gives you all the info you need to make a smart decision.
Okay, so how does this digital nutrition label actually get made? It's a pretty fascinating process, and it's built on a few really key cryptographic ideas. Let's break it down.
So it all starts with this tiny building block called an assertion. An assertion is really just a single fact. It could be something like, this photo was snapped on a Nikon Z9 camera, or this image was tweaked in Adobe Photoshop, or even, this was generated by an AI model. Each one is just a small, verifiable statement of fact. Then you take all those individual assertions, all those little facts, and you bundle them together into what's called a manifest. The manifest is basically the complete, unabridged history of the file. It's a log that collects every single assertion in chronological order, creating this super detailed story of the content's entire life.
So, what keeps this history secure? That's where a digital signature comes in. It acts like a cryptographic seal of approval. When a creator signs the manifest, it gets locked down tight. This proves who signed it, and it makes the entire history tamper-evident. If someone changes even one tiny byte of data, that digital seal is instantly broken.
And here you can see the whole process in action. It kicks off the moment a camera that's enabled with this standard, is called C2PA by the way, takes a picture. Boom, the first manifest is created. Then maybe a journalist edits it. Those changes get recorded as new assertions. The manifest gets updated and signed again. Finally, when it's published online, that file carries its entire, unbroken chain of history right along with it.
But wait a minute, there's a potential problem here. What happens if the file gets separated from its manifest? I mean, how do you make sure this incredibly important history isn't just lost or deleted somewhere along the way? Well, this is where some seriously clever technology comes into play. Think about how the normal web works. A link points to a location on a specific server. If that server ever goes down or the file moves, poof, you get a broken link. But a technology called IPFS, or the Interplanetary File System, does things differently. A link on IPFS points to the content itself by using a unique digital fingerprint. What that means is, as long as a single copy of that data exists anywhere on the network, that link will never, ever break.
Now, if this whole idea sounds a bit familiar, it's probably because this is the same core tech that powers NFTs. By storing the manifest on a distributed network like IPFS, you're essentially creating a permanent, publicly verifiable, and unchangeable record of that asset's history. It can't just be taken down or secretly changed later.
Okay, so this all sounds pretty bulletproof, right? We've got a tamper-evident history, locked down with cryptography, and stored permanently. But we have to be real here. This system is not a silver bullet, and it has some pretty significant blind spots that we absolutely have to talk about.
So, the big question, is this a perfect solution? The short answer? No, not even close.
While it's a huge leap in the right direction, there are some major real-world challenges to overcome. Let's run through them. First up, privacy. These manifests can hold a ton of data, and some of it could be really sensitive, like your exact location. That's a concern. Second, it's not foolproof. A determined attacker can just strip all this data off or try to fake it. Third, and this one is a really big deal, it only verifies where something came from, not if it's true. A perfectly real photo of something that's a complete lie is still a perfectly real photo. And finally, adoption. For this to really work, it needs to be everywhere, and we are just not there yet.
And then you wade into the incredibly murky waters of copyright. This quote about AI images really gets to the core of it. If an AI makes a picture, who's the author? Well, according to current law, there isn't one, and that means you can't copyright it. This makes the whole idea of provenance or origin really complicated when the very concept of ownership is totally up for grabs.
And that's not even getting into the bigger ethical debate here. These AI models are trained by scraping billions of images from across the internet, and that often includes copyrighted work from artists who never gave permission and were never paid for it. So while a manifest can tell you an image came from an AI, it doesn't even begin to address the messy origins of the AI's knowledge in the first place.
So where does all of this leave us? We've got this powerful new tool, but it's clearly imperfect and has to exist in a messy, complicated world. Let's take a look at what the future of trust might hold.
Ultimately, what we're in is a race. It's an arms race. On one side, you've got technology that can create flawless, undetectable fakes. And on the other side, you've got technologies like content credentials that are trying to build a new framework for trust. It's a constant tug of war between creation and verification.
And this, right here, is probably the most important thing to take away from all this. Content credentials are not some magic truth detector. They're a tool. They give you a trail of evidence, a set of clues about where an image came from. But that last, critical step, the decision of whether or not to actually trust what you're looking at, that responsibility, that's still on you.
Which really leaves us with one final lingering question. In a world of perfect fakes where AI can mimic reality flawlessly, is a digital receipt, a fancy nutrition label, really enough to rebuild our trust? That's a question I think we're all going to have to answer together.